Hi guys, welcome to the Support Vector Machine project solution lecture. We are going to work with a real dataset on credit card applications. I hope you have already solved all the tasks, but as a part of this course, let's move on and try to solve these tasks together. So the first thing, we need to import all these libraries. So let's run this cell and we are done with this import. So he's asking for read the data file and display the head of your data frame. So df equal to pd dot read csv and the file name is, if you press tab, it's going to be autocomplete. And then we need to display the head of the dataset as well. So df dot head and run this cell. And here we have the head of our data frame. The next one is the information on our data frame, a summary on the data frame. So df dot info and run this cell. Here we have 690 entries, 14 columns, and x1, x2, and so on. The third one, he's asking for the statistics. So we need to call describe on our data frame. So df dot describe and run this cell. And here we have the basic statistics on our data frame. We have count, mean, standard deviation, and so on. So moving forward to the exploratory data analysis, if you want, you can remove the hash and run this cell, and you will see how the pair plot looks like. So we are doing some assumptions here, and he's asking how many persons could not get approval. If you see, you have a target column in your data frame. So you need to grab the target column here and call the value counts on target column. So df grab the target and call value counts and run this cell. So 0 for not approved and 1 for approved. So the next question he's asking for, consider x8 as sex. 1 for male and 0 for female. Which sex have better chances for credit approval? Recreate the plot below. If you see, this one is a count plot and you have target along x-axis. So let's call count plot from cbound and grab the target column as x. So SNS dot count plot, and x is our target and our data is df. Let's run this cell, and here we have a count plot. If you see, you have to pass in hue as well, because you see it's split in 0 and 1 based on column x8. So let's pass in hue equal to x8. And if you want, you can set the same color scheme as well. And this one is cool warm. So palette equal to cool warm. And let's rerun this cell. And here we have the same output. So the next one is, considering x8 as a credit score, which score is the highest number of counts? Recreate the plot below. So once again, this is a count plot and you have to grab column x4. So let's call SNS dot count plot again and grab the column x4, and our data is df, and run this cell. And here we have this similar output. The only difference is our color scheme is different. So this one is once again rainbow. Let's pass in palette equal to rainbow and run this cell. And here we have the same color scheme as well. To answer his question, which score is the highest number of counts, we clearly see that 8 has the highest number of counts. It's more than 140 in this plot. So moving forward to the next question, once again, with our assumptions, x8 as sex, x4 credit score, what is the probability for male and female to get approved if the score is greater than 7? Create a count plot. In this case, you have to apply the condition on the credit score, which is greater than 7. This one is again a count plot, and x8 is along x-axis. So let's call SNS dot count plot. Our x is x8 and data frame is df, and now we need condition on our data frame. And what is the condition? X4 is a credit score and that must be greater than 7. So we need to grab the x4 column and apply the condition on x4. So df x4 and the condition is greater than 7. This is our masking condition and pass into df again. And let's run this cell. And here we have 0 and 1. If you notice, he is passing target as a hue as well. So let's pass in hue equal to target and rerun this cell. And here we have the same plot. So x8 is sex and 1 is for male and 0 is for female. This is what our assumption is. So the data clearly suggests that if the credit score is greater than 7, there is a high probability for male to get the credit approval, whereas for female, the credit approval rate is quite low, even if the credit score is greater than 7. So moving forward to the next question. So our assumption is x1 is the age column. What age is common for people to apply for the credit? So we have to recreate this plot. If you notice that you have approved and not approved, this is a histogram and the condition is on target column grabbing the age column, which is x1. Let's start with creating an empty canvas, a figure object. So plt dot figure and pass in fig size equal to 10 and 6, and our masking condition is approved and not approved. 1 for approved and 0 for not approved. So df grab the target column. If it is equal to 1, and this one is our masking condition, pass into df, grab x1 and call the histogram. So what we are doing, we are passing the condition on target column for approved and grabbing the age column and plotting the histogram. Let's copy this one, paste it here, and now the condition is when target column is 0 for not approved. Let's rerun this cell, and here we have something similar. We got the two plots, the color is different, the bin size is different, and we need to adjust all the parameters that we can play with. Let's set the color and bin size. So color equal to 1 is blue, which is for approved, and red for not approved. So this one is approved and the color is blue, and bins equal to 30, and we need to pass in the label as well, which is approved. Label equal to approved. Let's copy these parameters and paste in the second line, and instead of blue for not approved, this is red and not approved. Let's rerun this cell, and here we have red and blue histograms. If you notice, he's passing alpha as well, so we need to control the transparency as well. alpha equal to 0.5. Let's pass in both of these plots and rerun this cell. This looks much similar to the output what he's asking for. We have to set X label as age, and we have to display the legends as well. So let's split this code into two lines. So let's display the legends. So plt dot legends and then plt dot x label. I hope you know all these little things after this much practice. Let's rerun this cell, and here we have approved, not approved, age, and we got the same output now. Just a quick overview on this plot. We are using plt dot figure and setting the fig size. Then we are grabbing x1, which we consider the age column based on the condition on target column for approved as 1 and for not approved as 0. And then putting both histograms on the same canvas. And then setting some parameters, alpha, color, bins, and labels, and then displaying the legends, and then setting the X label. I hope it should be very simple to you at this stage. So moving forward, consider x12 is amount in thousands. How x1 and x12 are related. This should be related. Create a joint plot. This should be very simple now. Simply you need to call SNS joint plot and pass in x and y. So SNS dot joint plot, our data is df, our x is x1 and x12, x1 and x12, x1, and our y is x12. And let's run this cell, and here we have the same joint plot. So moving forward to the machine learning section, do the train test split, use test size 0.30 and the random state, which is default value. We need to do import first. From Scikit-learn dot model selection import train test split, and then separate the features to x. We can use df dot drop, and we need to drop target column along x is 1 and our y is what we are dropping. Let's run this cell, and we have x as features and y as target. And let's do the train test split. Press shift tab here, simple way, move down and copy this code, paste it here, do the adjustments and set the test size to 0.30 and run this cell. And we are done with the train test split as well. The next question is import SVC and create its instance SVM model. So let's do the import from Scikit-learn. If you remember from the previous lecture, SVC is a part of SVM. So Scikit-learn dot SVM import SVC, and let's create its instance as well. Let's name it the same one here. So SVM underscore model SVC. Let's run this cell. No error, so we have created the instance as well. Train the model, please. We have this instance. To train the model, we need to call fit and pass in xtrain, ytrain, and run this cell. And here we have the same output, and our classifier or model is trained on xtrain and ytrain dataset. The next one is do the predictions, please. For predictions, pred equal to SVM model and call predict and pass in test dataset and run this cell. There's no error, so we got the prediction in pred from our trained model, svm_model. How the classification report and confusion matrix look like. So let's add the code in the same line where he is importing classification report and confusion matrix. We can do both import and print at the same time. So print confusion matrix, pass in y_test and pred. Copy this line, paste it again, and change from confusion matrix to classification report. And what we are doing, we are importing and printing in the same cell. And let's run this cell. And here we have the output. So the output is slightly different. I've just checked from the solution notebook where the test size we have used 0.33, but in this case we have used 0.30. If we change the test size and repeat the steps, we will get the same output here. Let's go back and change the test size to 33 and rerun this cell again, create instance, train our model, do the predictions, and print the classification report. And here we have the same output. So if you use the same random state and same test size, you're going to get the same output. So instead of 30, it should be 0.33. So moving forward to the grid search, let's run this cell to create a dictionary of parameters, and then parameter values are given. Do the grid search to find optimum value of C and gamma. So let's find out the optimum value for C and gamma. So we need to import grid search CV from Scikit-learn dot model selection import grid search CV and create its instance grid search CV, and we need to pass in our classifier, which is svc, and the parameter grid, and this one is our parameter grid, and he's asking not to pass web rows. And at the same time we need to train our model as well. So grid dot fit, pass in x train, y train, and let's run this cell. So here we have the same output. So we got the grid trained on x train and y train. You may want to know the best values of your parameters. Let's check the best values of your parameters. So grid dot best and run this cell, and here we have the same output. Do the predictions using best values of your parameters and print confusion matrix and classification report. Should be very simple now. We need to get the predictions. So grid pred equal to, the similar way we need to call predict on grid, because this is a meta estimator now. Predict, pass in x test, and run this cell. And let's print the classification report and confusion matrix. And pass in y_test and grid pred. Copy this line just to save some coding or typing, and change this to classification report and run this cell. And here we have, with grid search you have seen the improvements in your model. So this was all about the exercise solution on the project. I have provided another optional project in the next lecture, and I will give an overview on that project in the next lecture. After that, we will move on to the next machine learning algorithm. Practice is a key. Try to practice as much as possible. Explore more datasets from UCI Machine Learning Repository and Kaggle, and practice your skills. See you in the next lecture. Good luck.